Hello and welcome to the third video in the series Griscom and land use land cover change analysis. So last video we were actually able to draw out a polygon using the freehand raster georeferencer tool in QGIS for the Mozambique reserve that we are concerned with. Um, However, in this video, before we step into actually reducing and finding the Griscom estimates of deforestation potential, I felt that we should be trying something else. And if you remember in the last video where we got given that image from Mozambique, we also got given this funny table with some XY coordinates where we didn't really recognize what system it was in. So I actually went and tried to look up what was the onshore coordinate reference system for Mozambique, and I found that the EPSG2736 coordinate system seems to have some coordinate set that looks like this. Look at this. Seems second number seems to be something like 7 million point four. The first number seems to be something called something like 194,556.82. And what I realized is if we took the last three numbers after the comma on this coordinate system as decimals, we seem to end up in that coordinate reference system. So these coordinates are actually in a system called EPSG 2736. So then, just given the points, can I actually use this information to draw out the polygon, right? That is the other question I'm currently working with. So basically, for that, thankfully, in the past, I've actually developed a piece of Python code where, given a set of coordinates, we can actually sketch out the polygon. So I'm going to go and download that and try to use that tool again in the present to try to solve for this. So this shaper.ipy notebook is the one that I want to work with. I'm going to put it in the Mozambique folder because we're really only using it to construct the Mozambique file. So to work with this, I'm going to open up a new terminal where I want to run Python, and I will say I'm using Anaconda. So I'll say conda activate GEE, which is the name of the environment in which I have all the geospatial libraries, which I would probably want to use. So I go into my Google Earth Engine GEE conda environment, and I will say cd downloads. I'm going to get to the Mozambique folder, and here I will launch Jupyter Notebook. Uh, I want to start working now in Python to get it. So this is shaper.ipy notebook is the file that I'm looking for. I don't really need any inputs here. I just need to provide coordinate systems, and it's going to give me allow me to save the polygon as a shapefile. So as you can see here, it imports pandas, geopandas, and shapely.geometry. From shapely.geometry, I import a class called polygon. Okay, so I think we don't really need this piece is really, if I have a polygon already, I can read it and see what it saves, what information it has in its geometry field as coordinates. I don't need to use this code cell, but this where it says EB Batike, it's actually, I have used this in the past in order to be able to draw out a bunch of polygons for EB Batike, which is in DR Congo. I don't really need that, but maybe what I'll do is add a cell now that we are drawing this out for uh, Mozambique. Uh, so we're going to start trying this out for Mozambique. Right, so I'm going to copy this code. We're not going to run anything below that. So we're going to have to provide a list of latitude points. And now, funnily, we don't know whether X is latitude or Y is latitude. This is always the challenge when we run into different tools. We get different when we get given coordinate systems. Sometimes you get it in latitude first, sometimes you get longitude first, but I'm going to have to make an educated guess and try to go with latitude first. So I want to jump back into my Python list, Python, and I will just put all of these as the list of latitude points, right? And I don't think we need the comma here, so I'm going to remove the commas there. It causes some confusion because these are numeric coordinates and don't want commas messing things up. So that's great. Now I'm gonna go bring from here the longitudes, right? Let's copy that in here. So we just need commas after each of these, but we don't need these commas. So I'm gonna remove all of those. Okay. So now next step will be using this Latin long to go and create a polygon using which I using the Shapely library of Python. So I've deleted all of this. So it says polygon geom is equal to polygon zip of longitude, point index, and latitude. Okay, so one way or the other I seem to have to lay out longitude first. It's okay. And then I'll construct, I imported GeoPandas here as GPD. So what this is doing is trying to construct a GeoPandas data frame, and it is going to set the CRS, and it is setting the CRS to EPSG 4326. We know for certain that we're not operating in EPSG 4326. We're operating in EPSG 2736, right? So I'm going to put 2736 here. That's what we're doing. And obviously for geometry, we're going to feed in polygon geometry. And we don't just want to write it to file just yet. I actually am going to go and set polygon dot, I think, set to CRS. Yes, that's the one. I will confirm this. So, and that's to CRS. That is, so GeoData frames have a method in the GeoPandas library called toCRS, which allows you to project from one CRS system to another CRS system, right? And I just want to check how the usage, I only need to ensure what I want to convert into. And yes, obviously we want to convert into WGS84, which is the most popularly used convention, uh, which I was using in QGIS earlier. So I want to convert it to 4326, and then I want to save the file. I want to save it right there as Reserva Recreativa perhaps, and I will save it as from Shaper, so I know that this is the one that is saving it. And that is really it, and I want to save it as an S3 shape file. So we can start executing this, and let's start by running this code cell where I imported the libraries. And I just need to run this, and hopefully it runs. It has. Brilliant. So now if I go and see here, I have this polygon here, RR from Shaper. Brilliant. And now I have the ability to look at that. Okay, let me take away the polygon that we drew. Let me take away the region of interest here. And let me try to pull in what we have just created using Python. And I just want to see where it shows up. And it is asking me source CRS is TET. Destination CRS WGS84. Absolutely. It's got it perfectly right, and it seems to be bringing it in somewhere in Mozambique. Fantastic. Okay. Come on, now where is it plotting this polygon? Seems to have done all the work. Just need to be able to observe it. We can do that. Zoom to layer. Oh, brilliant. It's somewhere in the sea. Ah, gosh. And in Australia. That is definitely incorrect, right? So what we know has happened here is it has mixed up the latitude and longitude coordinates. That's what it's done, right? What does the shape of this look like? This part needs to be in here, but I think it's flipped. Also, it's flipped on its head for some reason. It seems to be an inverted polygon, if you can see it. Just the way this thing looks versus the way this thing seems to look. This is definitely causing some trouble. There's some kind of lateral inversion that's going on. And also it's placing it in Australia, so that's not correct. It seems to have drawn the right kind of relative distribution is right, but it's in Australia. The one thing I can think of right now is to go back to Shaper and maybe make this longitude, this latitude, and let's see where that gets us. Seems to have resaved now. The what it has saved here is the refreshed Shaper files. So I'm gonna get rid of this layer and I'm gonna pull in the one I just created into QGIS, and I'm going to try to zoom to layer here, and now we're in Mozambique. We are exactly in Mozambique, and the polygon is almost exactly where we drew our earlier polygon. So we were really close from the raster georeferencer, but we are even more precise because we've generated this straight out of the coordinates they have given us. So I think we should just stick with this as the final layer. So with straight success that we know exactly where the plot we're looking at now is. So I'm just going to save this as a shape file now. And this is going to be a region of interest. And I'll save this as RR dot shape. This is the one that we are going to be looking at from now on. Excellent. This is the one we want. Can save this file. Fantastic. So it was just about latitude, which was latitude and which was longitude, determining whether we end up in Mozambique or we end up in Australia. Okay, brilliant. So this is done. In the next video, we will just use the Griscom data set and these two uh, region of interest files, the RR for Mozambique, the other one for Indonesia, to build our estimates. All right, brilliant. Hope you learned something in this video. Thank you. See you in the next one. Okay, I need to close it here.